All right, let me share my screen now. Let me share my screen. I believe we can see my screen. I believe we can see my screen. All right, so all right, welcome Destiny. I can see you now. Awesome. So we started differential calculus last class, and if you have not watched the video, please ensure you go and watch the video. This is the part 3 of the class. So I said calculus is a branch of mathematics that deals with change, right? And differentiation, we are trying to find the change between one variable and another variable. So you are finding a change from one variable with respect to the other variable. All right, so we started a couple of stuffs on calculus last class. Okay, I wouldn't do any revision. We can go back to the video and check. So we talked about method of differentiation. We talked about first principle last time. Talked about the general formula. We finished up function of function, which is also chain rule, and we've also covered product rule. So today, or right now, I'm going to be covering quotient rule. So let's start with quotient rule. Awesome. So I'm going to increase my screen right now. So let's go. Let u be equal to u over v, where your u and v are functions of x. And also note that your v is not equal to 0. All right, so let's assume we have our y to be equal to u over v. We're having it in form of a fraction now. So that idea that will come to your mind is use of quotient rule. So we want to show right now that if you differentiate this function with respect to x, we are going to have v du over dx minus u dv over dx, then everything over v squared. So this is the formula for quotient rule. So let's show it right now. Let's show it. Awesome. Okay, so let's start from what I gave us. Want to prove it now? If we have y to be equal to u over v, the first thing we did last time, I said we increase y by adding delta y, find that change. Then you did the same thing to u, that'll be u plus delta u, then everything over v plus delta v. So the next thing is to bring this y to the other side. So we're going to have delta y to be equal to u plus delta u over v plus delta v minus y. So that'll be delta y will now be equal to u plus delta u over v plus delta v. So what is our u? Our u from what we're given is what? Our y from what we're given is u over v. So we're going to have it as u over v. So let's find the LCM. If you find the LCM will be the product of both denominators. So that will be v into v plus dv. That's our LCM. So when you take v plus dv in this LCM, it will cancel one another. So we are going to be left out with v. So use that v to multiply the numerator. So that will be v into u plus delta u minus. Now, v in this denominator also will cancel out v, leaving us with v plus dv. So use v plus dv to multiply the numerator. We are going to have u into v plus delta v. All right. So let's open up the brackets. So we're going to have delta y to be equal to, open up the brackets, we're going to have uv plus v delta u minus uv, then that will give us minus u delta v, then everything over v into v plus delta v. So this one is going to cancel out these. So we are going to be left out with delta y to be equal to v delta u minus u delta v, everything over v into v plus delta v. All right, so the next thing for you to do is to divide through. You're going to be dividing through by delta x. So you divide the left-hand side by delta x and also the right-hand side by delta x. All right, so we have delta y over delta x equal to, so you can decide to distribute the division of delta x to the two numerators. So that will give us v delta u over delta x minus u delta v, everything over delta x, then everything over v into v plus delta v. I believe you're not confused at this side. All right, let me just explain that. You are dividing both sides by delta x. So this one divided by delta x straight up, and the whole of this divided by delta x, right? So when divided by delta x, you can have it as times 1 over delta x. So you can take this one, give it to this and also this. So that will result into this. It's just a normal way of solving maths. All right, so now this is what we have. We have dy by dx to be equal to v and the whole of this. Now, the next thing we're going to do, like I've always been telling us, when you get to this junction, after dividing through by delta x, find the limit. Find the limit as delta x tends to 0. Find the limit as delta x tends to 0. So one thing we should note here is that we're not having delta x alone. We also have what? Delta u and delta v. So we are taking the limit also as delta u tends to 0 and as delta v also tends to 0. Delta u tends to 0 and delta v tends to 0. What that means is this. What will happen to the left-hand side? Delta y over delta x will become dy by dx, like I told us. So wherever you see delta u standing alone, or delta x standing alone, or delta v standing alone, you make it 0. So we're going to have v. So delta u, delta x is not standing alone here. So this becomes what? Du by dx minus u. Delta v and delta x also is not standing alone. We're going to have dv over dx. Then everything over this one, if you open up the bracket, you're going to have v squared. Plus, this one is standing alone, so it's going to give us 0. So that's it. So our final answer is going to be delta y over delta x, or sorry, dy by dx equal to v du by dx minus u dv by dx, everything divided by v squared. So this is the formula for quotient rule. So we have just successfully proven this. All right, now let's see the application now. We want to solve questions there. All right. If you are getting me, can you just indicate? I believe you understand what I just did now. All right, so let's solve questions. Let's solve questions, practical questions. Okay. Questions. So find the derivative of the following. So let's assume the first one is y equal to 1 plus x squared over 1 minus x squared. Let's just solve 3 questions. Then the second question, y equal to x plus 2, everything raised to power 3 over the square root of x minus 1. Then the third one, let's assume we have the Cube root, write it well. We have the cube root of let's say 1 plus 3x square, then everything all square divided by x. So this one is also equal to y. So one of the way to easily identify if you are going to make use of quotient rule to differentiate is that you're going to be having it in fraction. I told us about product rule. Two things will be multiplying themselves, right? While this time around, you have fraction. So let's go. Let's start solving them. So for the first one, y equal to 1 plus x squared over 1 minus x squared. The first thing is to identify your u and identify your v. Please, the order is very important. Let the upper one be your u and let the lower one be your v. So let's go. Let's say let u be equal to 1 plus x squared. Now at the same time, let's let v to be equal to 1 minus x squared. Then the next thing is you're going to differentiate u with respect to x. If you differentiate u with respect to x, 1 is going to give us 0, then x squared will give us 2x. And if you differentiate v with respect to x also, 1 is going to give us 0, and this is going to give us minus 2x. So when you're done with this process, then the next thing is to do what? Apply the formula. So now let us apply the formula. And what does the formula say? It says dy by dx equal to v du by dx minus u dv by dx, everything divided by v squared. All right, so let's go. Slot in the value for your v, that is 1 plus, 1 minus x squared, slot in the value here. So we are going to have 1 minus x squared. Now slot in the value for your du by dx. This is du by dx, slot in the value. That will be times 2x minus, now go to your u now, slot in the value for u. This is the value for u, slot it there. 1 plus x squared times, this is your dv, slot in the value for your dv, that is minus 2x. That's minus 2x. Then everything over v squared. All right, what's our v again? Our v is this. So everything over 1 minus x squared, everything all squared. So the next thing is just to express them to the lowest term. Now let's open up the bracket first. 2x multiplied by 1 is going to give us 2x minus 2x multiplied by x squared is going to give us minus what? Minus 2x raised to the power 3. Then open up the brackets. Do this first to avoid confusion. You have minus into brackets. Use minus 2x to open up this one. You're going to have minus 2x. Use minus 2x to open up this one also. You're going to have minus 2x cubed. All right, everything divided by 1 minus x squared, all squared. Okay, I hope we're together. So we are going to have dy by dx to be equal to, open up every bracket we have at the numerator. We're going to have 2x minus 2x cubed plus, this is going to give us plus 2x. And also this is going to give us plus 2x cubed, everything about 1 minus x squared all squared. All right, let's go through it again for those that do not understand. So this is the question we're giving. Let the first one be your u and let the second one be your v. So differentiate u with respect to x, you're going to have 2x. Then differentiate v also with respect to x, you're going to have minus 2x. Then after that, you slot in all these values in your formula. That's what we did. Where we have v, we slot in the value for v, that is 1 minus x squared. Where we have du, we slot in the value for du, that is what? 2x minus, where we have u, that's 1 plus x, we slot in that value. And when we have the v, we slot in the value. So the next thing we did was to what? Open up the brackets. Use this 2x to open up the brackets. You're going to arrive at this. Then at the same time, use this one to open up the brackets. we're going to arrive at this. All right. So, well, I believe we are together now. So now let's see what can cancel out each other. Minus 2x cubed can cancel out minus 2x cubed. And then we have 2x plus 2x, which is going to give us 4. So we're going to have 4x divided by 1 minus x squared, everything else squared. At this point, there is nothing you can do about it. So that's your final answer. Now let's go to the second question. This question, this other one, question 2. Let me copy and let's solve. Okay, let me copy again. Sorry. Okay, now let's solve the second question. You're still going to use the same idea we just used now. Identify your u and identify your v. So let the numerator be your u and your denominator will be your v. So let's go. So our u is going to give us x plus 2 all raised to the power 3. Then our v also is going to give us what? The square root of x minus 1. Now let's differentiate u with respect to x. If you differentiate this, like I said, I taught us some, what's it called? Function of function, which is association rule. Differentiate what is inside here, you're going to have 1. Then multiply it by differentiating everything here. That will give us 3 into x plus 2. Then 3 minus 1 will give us 2. That's it. Now let's do dv by dx. First of all, you can express this one like this. Raised to the power 1 over 2 to make it easier for you. So now it will be easy for us to differentiate. So differentiate what is inside. You're going to have 1 multiplied by, then differentiate everything together. That will be 1 over 2 into bracket x minus 1. Then take away 1 from here will give us what? Minus half. All right. Believe we recall how to differentiate very well. If you have y equal to ax raised to the power n, if you have to differentiate y with respect to x, you're going to use the power here to multiply this. That will be n times a. Then you take away 1 from here, n minus 1. So remember this. So that's just the principle we used to differentiate both this and this. All right, now let's apply the formula now. The formula is dy by dx to be equal to v du by dx minus u dv by dx. Everything divided by v squared. So let us identify our v. Our v is this. That's x minus 1 all raised to the power half, raised to the power of half. Multiplied by, what's our du by the x? Our du by the x is 3 into x plus 2 all raised to the power 2. Then minus, what's our u? Our u is x plus 2, everything raised to the power 3. Then our dv is half into x minus 1 all raised to the power half, raised to the power minus half. Then everything divided by v squared. What's our v squared? Our v is x minus 1, then everything all squared. All right, whenever you're solving questions under differentiation or any kind of mathematical question, do not be scared. Whatever question you're given, there's always an answer or solutions to every question. That was one of the things I discussed with some of my students today. You always have solution to every question. All right, let's see. Let's see how we can factorize this or make it very simple. So for the first one, x plus 2 is actually common to both ends. So we can factorize that expression out. X plus 2 all squared is common. So that will be x plus 2 all squared. That's common. So if you bring that out, you're going to be left out with x minus 1 to the power of half. Let me put 3 here. That will be 3 into x minus 1 to the power of half. Then minus, if you take out x plus 2 all squared here, you're going to be left out with x plus 2. Now let's put half. Then you're left out with what? X minus 1 to the power of negative half. Everything over. Now, if you look at this, well, 2 here can divide this one. So we are left with just x minus 1. Okay, we can also do some other things. All right, let me see some comments. Are we together? Awesome. All right, so you can stop at this junction and we can still continue. Let's see. Is there any other thing we can do about it? There's a lot of things, but I don't want to complicate it. So we can stop here. You can stop here. The other things coming to my mind, let me just talk about it now. This one can be expressed as 1 over this. Let's go through that route and see if it's gonna work. It's gonna work, obviously. All right, let's go through that route. So we have x plus 2 all squared into brackets. It's just gonna be big x minus 1 to the power of half minus 1 over 2 into x plus 2. Everything also x minus 1 raised to the power half. Do we get that? Like I told us, law of indices says that if you have x raised to the power minus 1, it's the same thing as 1 over x. So if I have x raised to the power minus a, is the same thing as what? 1 over x raised to the power a. So now that I have x raised to the power minus half, is the same thing as what? 1 over x minus 1 to the power of half. Right, so that's the only thing I did there. I didn't do anything confusing. All right, then divided by x minus 1. So I can put that one here, x minus 1. So let's go. So we're going to have x plus 2 all squared over x minus 1. Then let us find the LCM here. The LCM here is going to be obviously going to be 2 into x minus 1 all raised to the power half. So when you multiply this by this, it's going to give us the whole of this. So you're going to multiply, that will be 3 into x minus 1 half times what? 2 into x minus 1 raised to the power half. Okay, so then the other one will give us minus the whole of this in the LCM will give us 1. 1 multiplied by what we have on top is going to give us x plus 2. All right, so let's go further. I'm just trying to break this down so that the equation is easier. So we're going to have x plus 2 all squared over x minus 1. So if you look at this, 3 times 2 will give us 6. Then this is going to give us x minus 1. How do I get that? All right, let's assume the whole of this is x raised to the power half multiplied by x raised to the power half. According to the law of indices, what did you do? You add up their power if you have multiplication in between them. So when you add up half plus half will give you what? 1. That's why I have it like that. Do we get that now? So that's that. Then minus x plus 2 into 2 into this. All right, let's see. Is there any other thing we can do? Then we can stop here. We can stop here actually. Okay, now I want you guys to try out this question so that I can move on to some other things. Try out this question. This question 3. So whenever you have any kind of fraction, you're just going to make use of differentiation of quotient rule. You use quotient rule. All right, now let's go to another kind of differentiation to meet up with our time. So now let's talk about differentiation of implicit function. Differentiation of implicit function. So every differentiation we've been doing since is explicit function because we have been having our question to be in form of y equal to f of x, right? Exactly. So we are differentiating y with respect to a particular function. So that kind of differentiation is always called an explicit differentiation. Now, if I have a situation where we're having something like this, you're not just differentiating a variable with respect to another variable. Right now, you are differentiating both variables together. This kind of expression is called an implicit differentiation. Is an implicit function rather. So you make use of implicit differentiation to do that. So whenever you have any question like this in this form, you don't use the normal conventional way. We call it what? Implicit differentiation. All right, now let's go through some examples. It's straightforward. Now let's solve some questions. Okay, let me call them examples. Differentiate the following. Differentiate the following. The first question is x squared plus y squared equal to 4. The second one is let's say x squared y plus y squared x and plus 4x equal to 1. Let's just do 3 so that we can come to the perfect understanding of this. 4y squared. This is 4y squared x minus 5x squared y cubed plus 4y equal to 0. Awesome. Now let's go. Let's go. Solution. Now let's look at the first one. We have x squared plus y squared to be equal to 4. So you have the basic understanding of differentiation. So you're going to make use of that same basic understanding of differentiation. Differentiate x. That will give us 2x plus differentiate y. That will give us 2y. But whenever you differentiate y function, just include the y by the x at the back. Include the y by the x. Then if you differentiate 4 now, you are going to have 0. If you're with me, can you just indicate? Can you just type yes? If you're getting it, type yes. If you can see my screen very well. Okay. So now the next thing is to make dy by the x the subject of the formula. So we have dy by the x to be equal to subtract 2x from both sides. That will give us minus 2x. Don't forget we have 2y behind this. Then the next thing to do now, divide through by 2y. Divide through by 2y. So that will give us dy by the x equal to minus 2x over 2y. So our dy by the x is going to give us minus x over y. So that's our answer. Please indicate on the chat box if you are still together, if you can still see what I'm doing. Indicate on the chat box. Awesome. Thank you very much. So that's our answer. That's our answer. All right, now let's consider the second question. So if you didn't get the first one, look at the second one. You're going to get it. So this is the second one. This time around, we're not just having x standing separately, neither do we have y standing separately. Both of them are standing together. So in this kind of scenario, what you would do is this. You first differentiate the function with respect to x. Treat the other variable as constant, then treat the second variable, differentiate the second variable, then treat the other one as constant. What I'm saying is this. Look at my screen here. I have x squared y. The first thing to do is to differentiate with respect to x. Differentiate with respect to x. That's the meaning of DWRT x. Differentiate with respect to x. So you're going to treat y as constant. If you differentiate x here, what will we get? We are going to have 2x. Then you multiply by what? By 1. Do we get that now? So the next thing is also differentiate with respect to y. So you are going to be treating x like a constant now. So if you differentiate y here, you will have 1. Then multiply the 1 by x squared. That will give you what? X squared. And I said it, whenever you differentiate the function of y, always add what? Dy by the x. So you had both of them. So now bring this into this. So we have done this. Differentiating x will give us 2x, then y, plus differentiating the function of y here will give us 1. Then 1 times that x will give us x squared. Then you add what? dy by the x behind. So we are done with that. Plus, do the same thing for this second function. Differentiate everything with respect to x. If you differentiate x here, you have 1. Then 1 times y squared will give us y squared. Similarly, differentiate everything with respect to y. It will give us 2xy or 2yx. Then I said that when you are done with differentiation with respect to y, you had what? The y by the x. So that's it. So now move on to the 4x squared and differentiate with respect to x. You're going to have 4. Then differentiate 1 with respect to, just differentiate it, you will have it as 0. Whenever you differentiate the constant, it will give you 0. All right, so now let's make our dy by the x the subject here. So that means we need to take these other variables to the other side. So all we have here is x squared dy over the x plus 2yx or xy dy by the x. Everything will be equal to, when everything crosses over, we are going to have minus 2x plus y squared plus 4. Don't forget it. That's minus 2x minus y squared minus 4. So I included everything in the bracket. All right, so that's what we have left here. Then you can factorize dy by the x here. So if you factorize dy by the x, we are going to be having x squared plus 2yx into dy by the x. So this is going to be equal to minus, open the bracket, 2xy plus y squared plus 4. Then the next thing is to do what? Is to divide sides. Divide both sides by the coefficient of dy by the x. That is what? X squared plus 2yx. Divide both sides by that. So this will now give you what? Dy over the x to be equal to minus 2xy plus y squared plus 4, everything over x squared plus 2yx or 2xy. I love 2xy, but let's leave it that way. So this is our final answer. So implicit differentiation is very simple and straightforward. Just differentiate with respect to x, differentiate with respect to y. Then whenever you differentiate with respect to y, always add dy by the x there. Then after that, you make dy by the x the subject of formula, and we are done. So now let me solve the third question and move on to the last aspect for today's class. Okay. If you understand what I did, can you just type I understand? And if you don't understand, you have to go over the video again. If you understand it, I want to see us type I understand. I understand. I understand. I'm waiting for us. All right, very good. Now we have 4y squared x minus 5x squared and the likes. So like I said, the first function, differentiate it with respect to x. Don't be confused. See the other variable as a constant factor, like maybe 2, 3, 4, and the likes. So now let's go. If you differentiate with respect to x here, you're going to have just 1. Then use that one to multiply 4y. You're going to have what? 4y squared. We are done with that. Then differentiate this same function again with respect to y. What do you have now? You are going to have what? Now let me write it on the other side. So 4y squared x. Now we are differentiating y here. We already have 4 at the front. Let me write it to us so you'll not be confused. If you differentiate y here, it will give us 2y. Do we get that now? Now open up the bracket. 4 times 2, that's 8. Then 8 times yx, that is 8xy. Or 8yx. Just put it as 8xy. Write it alphabetically. Then I said whenever you differentiate a function of y, always what? Include dy by the x behind. Don't ever forget. For x, you don't need to include it, but for y, you must include it. All right, now look at this. We have minus 5x squared y cubed. Minus 5x squared y cubed. Differentiate the function with respect to x first. I'm going to write it here. Differentiate the function with respect to x. So we have 5 into, this will give us 2x, then y cube, then multiply. 5 times 2, that's 10. That's 10x y cube. Don't forget we have minus at the front, so that will give us minus 10x y cube. All right. Then differentiate this same function with respect to y. So minus 5x squared y cube. Differentiate with respect to y. Treat the other ones as constant. That will be minus 5x squared. If you differentiate y cube here, you're going to have what? 3y squared. Then open up the bracket, you have minus what? Minus 15x squared y squared. So that will give us minus 15x squared y squared. Then I told you always add the y by the x each time you differentiate with respect to y. All right, so that's it. Plus, now differentiate 4y will give us 4. Then you add what? The y by the x. Everything equal to 0. All right, the next thing is to bring out your dy by the x. Like, want to make it the side of formula. So take every other function to the other side. So we're going to have 8xy divided by the x minus 15x squared y squared dy by the x. Then plus 4 dy by the x. Then take the other everything to the other side there. That'll be minus, open a bracket, bringing 4y squared. That'll be 4y squared minus 10xy cube. That's it. Yeah, that's all. That's all. Okay, now the next thing is to factorize your dy by the x at the left hand side. So we're going to have 8xy minus 15x squared y squared plus 4. If you factorize that, you're going to have dy by the x to be equal to minus, open a bracket, 4y squared minus 10xy cube. Then at this point, divide through by the coefficient of dy by the x. So we are going to divide through by x, this, and that. So we will have dy by the x to be equal to minus, open a bracket, 4y squared minus 10xy cube. Everything 8xy minus 15x squared y squared plus 4. So that's our answer. So we are done with this. Please go ahead and practice a lot on implicit differentiation. It's actually straightforward. All right, so let me talk about the last aspect before we leave. If we are together, can you just type yes, please? If you're together, can you type yes? All right. So we've just finished up both quotient rule and implicit function. Now let's deal with trigonometric function. But before we deal with trigonometric function, there's a standard differential coefficient that we must all know. We can actually prove everything. So this is it. If I have my function y, f of x, the standard derivative, either you call it the y by the x, like I told us, or you call it f prime of x, any of the two. One of it is function way of writing it. Another one is the Leibniz way of writing it. So if you have an algebraic function, x raised to power n, the derivative is what? N into x raised to power x n minus 1. So this is when you have an algebraic function. Then for the other one, if you have what? An exponential function, we can literally prove everything, but I will not prove everything. So if you have exponential x, if you differentiate it, you always have exponential x. If you have exponential kx, if you differentiate it, what is on top will just come down. That's k exponential kx. When we get to exponential differentiation, you will see it. And this is also logarithmic differentiation. So if you have a logarithmic function, we call it natural logarithm. That's ln x. Or you can also have it as log. Either you call it ln x or you call it log. Then the rest are trigonometric function. From here down to here, we call it trigonometric function. Trigonometry function. Then this is hyperbolic function. So whenever you differentiate sine x, you are going to have cos x. Whenever you differentiate cos x, you will have minus sine x. So please, these are some standard differential coefficients that you must know. You must just know them, especially the trigonometric aspect. Your sine to give you cos, your cos will give you minus sine, your tan will give you sec square x, then your cot x will give you minus cos x square x, your sec x is going to give you this. So I'm going to prove sine for us, and I'm going to prove tan for us, so we can prove the rest. Because right now I want to deal with just trigonometric function. So now let's move down to trigonometric function. Okay. So if I have my f of x to be equal to sine x, and we are told to find f prime of x, we already know from the standard differential coefficient I just showed us now that it will give us f prime of x, definitely will give us what? Cos x. But how do we prove it? We can use differentiation of first principle to prove it. Okay, let me make it very fast so that I have several methods of proving it, but let me look for the shortest and the fastest. Okay, if you remember the formula for differentiation using first principle, how that if you have f of x, then f prime of x is going to give you what? The limit as h tends to 0 of what? F of x plus h minus f of x over h. And I told you that this h is the same thing as saying delta x or small letter delta. Is that you have it like this or you have it like this. So we did that in the last video, or delta x, whichever one, whichever one. All right, so let's use this one. So let's use this method to prove it. All right, so let's show. Let's prove. First of all, our f of x is sine x. Then the next thing is f of x plus h. Just do what? Add your h to this x. That's the next thing, right? So applying the formula now, the f prime of x, applying the formula f prime of x, which will be equal to limit as h tends to 0. What's our f of x plus h will give us what? Sine into x plus h minus what? Sine x. Everything over h. Okay, so now if you have done trigonometry before, that's one of the topic you need to understand well if you'll be dealing with trigonometric differentiation here. You will remember that the addition rule says that if you have sine a plus b, that sine a plus b is going to give you sine a cos b plus cos a sine b. So we are going to make use of this. We are going to make use of this addition formula from trigonometry identity. So just take note of it. Just take note of this. Take note of it. We are borrowing this thing now. We are using it from where? From addition rule in trigonometry, normal trigonometry. All right. So apply it here. We are going to have our f prime. I believe you know you can write your f prime as also the d of this. Right? You can write it like that. Don't get confused. So that will be limit h tends to 0. So applying that, sine x plus h. Using this one, sine a plus b will give us what? Sine x cos h plus cos x sine h minus sine x. Everything divided by h. I just like to prove, and I hope also all of you like to prove before you go into questions, understand how to prove it and the likes. So we're going to have limits as h tends to 0. So you can bring this together, sine x cos h, bring it together with minus sine so that we can factorize something out there, then plus cos x sine h, everything over h. All right, guys. Now let's factorize. Or before we factorize, also we can also split. This is factorize sine x here. If you bring out sine x, we are going to be left with cos h minus 1. Then you can split it. That will be divided by h. Then plus cos x sine h, everything divided by h. Now, when we do limit of function, you remember something that if you take the limit of sine h over h as h tends to 0, this is going to give you 1. Just recall this function. You can use L'Hospital's rule to prove this. Differentiate the upper one, the lower one, and substitute. Just recall, just take note of this. So if you take the limit as h tends to 0 of sine h over h, you're going to get 1. Similarly, if you take the limit as h tends to 0 of cos h minus 1 over h, this is going to give you 0. So that is proven from limit. So I'll cover that one in other video, how to find the limit of any function. All right, let's go. We can distribute the limit now. Just take note of this. So if you distribute the limit, you're going to have limit h tends to 0. For the first one, sine x into cos h minus 1 over h plus, can distribute the limit h tends to 0 of cos x sine h over h. Okay, now looking at what we have here, bring out your sine x. So you can have sine x into limit as h tends to 0 of what? Of course, h minus 1 over h plus, bring out your cos x into limit as h tends to 0. We'll cover the whole of this in limit video. Then that'll be sine h over h. Now, according to what we have here, this will tend to what? 1. So the whole of this will tend to 1, and the whole of this will tend to what? 0. So we are going to have sine x multiplied by 0 plus cos x multiplied by 1. So this will give us 0, and this will give us cos x. So that is your answer. That is why if you differentiate sine x, you're always going to have it as what? As cos x. I told you can have this one as f prime of x. So that is our answer. All right, so I will ask that you should try differentiating when y equal to cos x. You can use this same first principle and you get the answer. So you get the answer. I just showed us in standard coefficients that if you differentiate sine x, can you see it here? You're going to have cos x. Now differentiate cos x so that I can get minus sine x. Okay? So let me just do one more. So let's look at tan. Let's see how we can get tan. Let me quickly work on tan and let's see. So do this, don't forget y equal to cos x. prove that if you differentiate it, you're going to have it as minus sine x. All right, now let's do for tan. So if I have y to be equal to tan x, and I'm told to find the derivative or differentiate, find the y by the x. We want to know how tan x is going to give us sec x. So first of all, there are some knowledge in trigonometry you must understand. That if you have tan x, is the same thing as saying sine x over cos x. So this tan x becomes what? Sine x over cos x. Then I told us the other time that whenever you have a fraction, the next thing is to do what? Use quotient rule. So if you want to make use of quotient rule like this, you use what? Dy by the x equal to v du by the x minus u dv by the x, everything over v squared. So identify your u. Your u is the one on top and your v is the one below. So your u is your sine x and your v is your what? Cos x. So if you differentiate u with respect to x, if you differentiate sine, we just show that you will get cos x. And if you differentiate v with respect to x, if you differentiate cos x, you are going to get minus sine x. That's the one I said you should go and prove using first principle. All right, now let's apply the formula. So your dy by the x is going to be equal to, what's our v? Our v is cos x multiplied by, what's our du? Our du is cos x also, minus, what's our u? Our u is sine x times, what's our dv? Our dv is minus sine x. Then everything about v square, what's our v? V is cos x. That'll be cos square x or cos x square. It's going to give you the same thing. Okay, so we're going to have dy by the x to be equal to cos square x minus, sorry, that'll be plus sine square x, because minus sine x times minus sine x will give us that. So here we are. According to the first trigonometric identity, sine square x plus cos square x is going to be equal to 1. So if you're going to be differentiating trigonometric function, you must have very good or solid background of trigonometry. So just remember this formula. That's sine square x plus cos square x. Either way around, whether cos square x or sine square x is going to give you 1. So we are going to have dy by the x to be equal to, this is 1 over cos square x. All right. Now, according to trig reciprocal, if you have sec x, is the same thing as saying 1 over cos x. If you have cosec x, is the same thing as saying 1 over sine x. And if you have cot x, is the same thing as saying 1 over tan x. One of the way I used to remember, look at the third number, or third letter, sorry. The third letter is c, that'll be 1 over cos. The third letter is x, that'll be 1 over sine. The third letter is t, that's 1 over tan. All right, this is trigonometry reciprocal, so you must know. Don't worry, when you do trigonometry, you understand it better. But those are the things we need for now. So that will be dy over the x, so now be equal to 1 over cos x is what? Is sec. Now that we have 1 over cos square x, that will become what? Sec square x. That's the reason why if you differentiate your tan function, you are going to have sec square x. Can we see it here now? Can we see it now? All right. So I solved 2 examples and we are done, so that we'll not just understand the concept and not know how to solve question on it. Find the derivatives of the following. Number 1, let's say we have our y to be equal to cos 2x. Then the second one is y equal to tan into 2x minus 5. Let me make it more interesting. Let me make it 3x all square. All right, let's solve the 2 question. Now, if you remember chain rule very well, function rule, I told you when you have something enclosed in something, that's when the idea to use chain rule will come around. So now that's the same idea you're going to use here. I'm going to teach you the normal way of solving it, and at the same time, I'll teach you the shortcut to solving it. So the first thing is, what is enclosed? That is 2x. Is enclosed in the function of course, right? So let u be equal to 2x. If your u is equal to 2x, you can rewrite your question to be like what? Y will now be equal to what? Cos u, because you have replaced it with 2x. Now the next thing is to differentiate u with respect to x. Find du dx. Du dx will give you what? 2. Then the other one is to what? Find dy by du. Differentiate y with respect to u is going to give you what? Sine u. Sorry, minus sine. Do we get that now? Just chain rule idea. So your dy by dx will be the multiplication of your derivative. Dy by dx times what? Dy by du, which is equal to what's du by dx? That's 2 multiplied by dy by du is what? Minus sine u. So dy by dx, our answer will be minus 2 sine u. But don't forget that we do not have u from the question. We replace that u. So go back and substitute it there. So that will be minus 2 sine 2x. That is the answer. All right, let me give you a short trick to solving this kind of question. It's still the same short trick for chain rule. What's the short trick? Y equal to cos 2x. First of all, let u be equal to 2x. Sorry. No. Shortcut, I said shortcut. All right. Differentiate what is inside. Your dy by dx, differentiate what is inside. If you differentiate 2x, you're going to have 2. Then differentiate this cos function. That will give you what? Minus sine. Add your 2x there. That's what? Minus 2 sine 2x. That's the answer. So that's how short it is. All right, now let's do the last question. And we're done for this class. Okay, so we're told to differentiate y with respect to x, and this is a trigonometric differentiation. Like I said, what we have enclosed in the bracket, use an alphabet or use an alphabet to replace it. So let u be equal to 3x squared minus 5. Rewrite your question, then your question will be y equal to tan. The other of this has been replaced by u, that will be tan u. Then the next thing is to differentiate u with respect to x. Find the u dx will give you, multiply this by this, that will be 6x. Then minus 5 is gone. Then differentiate y with respect to u, that will be dy by du, which is equal to what? If you differentiate tan u, like we just showed now, that will be what? Sec square u. Then multiply your derivative. That will be du by dx multiplied by dy by du. So what we have here is what? 6x times sec square u. Like I said, we do not have u from the question. We derived the u ourselves, or we brought the u ourselves. So go back and replace your u there. That will be what? Into 3x squared minus 5. All right, so that's our final answer. So trigonometric differentiation is actually very simple. Once you have the knowledge of chain rule, you can do it. Okay, now let me do the shortcut again. So what's the shortcut? Y equal to tan 3x squared minus 5. Like I said, differentiate what is inside first. If you differentiate what is inside, you're going to have 6x, right? Multiply it by differentiate tan function will give you what? Sec square. Then write out your function at the front. That's 3x squared minus 5. That's your answer. So you're going to have 6x sec squared into what? 2x squared minus 5. So obviously, you are going to get the same thing. All right. So, guys, you can play with this question. And if anybody solve it, just send it to my DM. If you have y to be equal to, let's say, sec, open the bracket, tan, open another bracket, sine into 3x raised to power 2 minus 5. If you're able to get the answer, you can just come to my DM and let me know. All right, so that's it for today. So that's it for today. So we're gonna stop here, and in the next class we will treat the rest differentiation. We'll treat the rest We're going to be treating, we've treated trigonometric function. So we have those parametric equation left, exponential function, trigonometric function, sorry, logarithmic function, and application. All right, guys. So let us have a beautiful day ahead of us. Bye, everyone.